Thank you for having me do this presentation for your group. If I had a choice, I'd actually try to be there. I've never been to Australia before. It's on my list of places to visit. It's just maybe someday I can actually make it happen. But this is the next best thing. So, yeah, thanks for having me. And I do have my coffee ready. So let's get started. My name again is Jason Bock. I am a practice lead in application development in .NET for a software consulting company called Magenic, which is based out of the Twin Cities in the state of Minnesota. And we have other offices across the United States and also an office in Manila in the Philippines. And my talk in this session is called Using the Compiler API in Real World Scenarios. So that's a little bit of information about myself. If you want to check out any of those sites, feel free and do so. If you have questions during the presentation, let me just make sure I have up on my other screen on my right the Q&A up. So if you do have any questions, feel free to throw them in there. I'll try to make sure I keep looking over there occasionally to see if anything gets posted there, and I'll try to answer them as best as I can. And David, feel free to get my attention if I'm ignoring things for too long, and I'll make sure I look over there. Otherwise, if anything comes up afterwards during the talk, just feel free to send me an email, jasonb@magenic.com, and I can answer it then. All right, so there's a fair amount of code examples that are kind of scattered across a number of repositories. So if you want, you can check them out later. These are the locations for them. And when I go through each of the demos, I'll make sure to call out which one it is that I'm doing. If you want, to copy all these down now would be kind of hard. The easier way to do it is just to go to the bottom repository. That's where I have links to all of my presentations that I've ever done, including this one. So probably the easiest would be is just to grab the slide deck and then copy them as you need them. On the last slide of this deck in the notes section, I have links to a number of resources. So you might want to get the deck because of that as well, and you can check those out later on if you'd like. So this is mostly demo driven. I'll spend a little bit of time up front talking about the compiler API, what it is, where it came from, and at a very high level what you can do with it. And then I'll just dive right into demos to show you how you can use it in different scenarios. All right, excuse me. So compilers, a lot of us, in fact, I'd say everybody who is a developer, and not even just in .NET, if you're using any kind of programming language, you're using a compiler or an interpreter or something that reads text and translates it somehow into something that executes on your computer. And in .NET, that compiler has at the start been a black box, which means that you just kind of use the features that are in it, but you're not able to access what is actually being done within the compiler itself. And for most day-to-day scenarios, this is fine. Most typical developers are just, whether they realize if they're in C# running CSC or F# is FSC, I believe. Even if they're in Visual Studio and they don't run that executable directly, that's what everybody is doing. Okay, and so that's the core piece of really what we do as developers. I mean, if there's any piece of machinery that we use more than anything else, I'd argue it's probably the compiler. It's a pretty important aspect of what we do throughout the day. And at a very high level, it seems pretty simplistic. You give it a bunch of files, you run the compiler, and out comes an assembly that then you can execute. Of course, if you've ever tried to write a compiler or look at any code for a compiler, it gets pretty complicated. There's a lot of things that need to happen within a compiler. But until the compiler was opened up in .NET, and I'll get to that in a moment, there really wasn't much you could do with it. The last time I counted, there were a number of switches that you could pass in, but that really only controlled, you know, a handful of gears, so to speak, within the compiler. You couldn't figure out, or you couldn't use the parsing stuff. You couldn't use any of the lexing stuff. You couldn't, none of that information. And there's a lot of rich information that gets generated during a compilation phase. You really couldn't see it. So again, for the most part, it's not that big of a deal, but there are a number of reasons why you'd want to have a compiler accessible from an API perspective. One of them is tools. I only list these tools here not because I have any type of relationship with these tools or I'm trying to sell you on them or anything like that. The reason that I put them here is because to some degree they all have to do things, or at least they did, they all had to add their own kind of understanding of C# code within their tools. So to provide refactoring capabilities, code analysis capabilities, and so on, which is fine. It's great that these tools exist, and I would imagine that in this list, a fair amount of people on this call have used at least some of these, probably. But you can also probably imagine how difficult it is for these tools to have to figure out, well, if we want to provide a refactoring, how do we know when to tell the user to do that? How do we handle the shape of the code, the parsing of the code? That gets very complicated. They're essentially writing their own parsers. And if you've ever looked at the specification for C# or how some of these language features work, the code gets really dicey in a hurry. Especially generics. There's an example that I saw once that showed where you have greater than symbols, less than symbols, commas in between, and the semantics around the code determines, is this a generic definition or am I doing a greater than or less than sequence of operations on numerics? It can get really hard to do that. And there should be no reason these tools have to write those things. That information is already in the compiler in C#. Okay. And another one is just features. If you look at the history of C# itself over time, the amount of features that was added in each version, especially around versions 4 and 5, the numbers start going down. In 5, they added async and await, which is a substantial feature that took a lot of time to do, but it started to become harder to build these features in, primarily because the compiler itself was written in C++ and C. So it's not to say that those languages prevent you from being fluid and fast. It just had some friction there to get things to work well and be adaptable to adding in new things. And also, there was all closed source. It was all within Microsoft. There was no ability for the community to really be a part of that process to add in features themselves. That's a hard endeavor, though, that has, as I'll talk about in a moment, that has been done. But to be able to look at the source code itself for the compiler was something that people couldn't do outside of Microsoft. Okay, so there's a fair amount of reasons why having this as a black box, not just from a API perspective, but also as an open source community perspective, was problematic. So open it up. Let's make it so that it can actually be something that people use. So it's not just a simple pipeline of what I showed before. All of the things that exist within the compiler are available for people to use. Okay, and that's what Project Roslyn was and still is. That was the code term, or the naming of the team within Microsoft. They called it Roslyn, Project Roslyn, and now it's technically called the compiler API. So that shows you Microsoft's love of naming things well. It's the official name, but so many people still call it Roslyn. And in fact, if you go on Twitter, the Roslyn account, that's the actual account for all the API stuff, compiler API stuff from Microsoft. So that's what this was. It actually, as I found out later from some people that worked on this, the first beginnings of Roslyn actually happened soon after version 1.0 was released. Apparently, somebody took the C++ code and either ran it through a tool or some other machinery to basically spit out C# code and said, hey, here's our compiler now written in our own language. That's another thing about the compiler APIs. It's no longer in C++, it's actually in C#. And that's a good thing, right? Writing your compiler in your own language actually has that aspect of doing like a dog food kind of aspect where you're eating your own dog food. You're using what you build. And so that happened relatively early, but it was kind of just, experiment, kind of a fun thing that somebody did. And then slowly over time, this started to become we really should do this. We really should actually build in our own language and maybe even open source this. But it took a long time for all of that to happen. By 2014 at Build, they announced that they had others that started to talk about Roslyn at some of the PDC events and other Microsoft events, and hinting at this thing called compiler as a service. Then the code names came out, Project Roslyn. There were some bits that people could play with in 2011. 2014 is when they announced that it was going to be the underlying compiler for C#6, and it was also when they announced it was going open source, which was a really big deal. Now, 6 years later, if somebody just looks at Microsoft now, it was, oh yeah, they do a lot with open source, but that was not the case for many years. So to see them actually take that step where they said, we're going to publish this and make this open source for people to look at, was a big step. They did it in Coplex, and they didn't fully open source everything. There were some false starts that they did in terms of how they handled it, but they learned rather rapidly how to handle the whole open source aspect of it, and they eventually moved it to GitHub, and that's where it lies now. So that's what I mean by the compiler API. That's what we're going to be looking at. And as you're going to see, there's a lot of things that exist within this API that you can use in your own applications for many different scenarios. There's a couple that they support with project templates. There's things called analyzers and code fixes, and also refactorings. They have APIs around those so that you can build things to tell people when they're doing something wrong, also provide them a code fix to change the code. You can provide a refactoring to say to somebody, hey, maybe you want to change this code to look a different way or act in a slightly different way. So there are those templates. There's also other APIs in there that you can use, and you can take those and build tools or build other NuGet packages or other things like that for really any scenario that you can think of. So it's kind of the sky's the limit. It is still, at the end of the day, an API that's dealing with compiler aspects. So you are going to see syntax trees. You do kind of have to understand how those work, what the semantic APIs are, symbols, and things like that. So my intent in this talk is not to go through all this. There's no way I could, but to kind of just give you a couple of examples that if you've never seen how this works before, to go, hopefully you'll think this is kind of interesting. Maybe I can start using these things on my own projects or for the teams that I'm on, and maybe we can speed things up or do things in our code in a little bit of a better way. Okay, so this hopefully to spark some ideas in your head. Okay. All right, so I'm going to jump into all the demos right now. And before I do that, let me actually just jump into the Visual Studio installer for just a moment. And the reason I'm going to do this is because there's a SDK that if you have not installed yet, I highly recommend that you do it because it's going to make some things easier to do with the compiler API. So to do that, let's see, not that, modify, there we go. There's an SDK that I highly recommend a download. It takes me a second to remember where it is. This is also, as a user of this, I wish they had a search in this window. That would help a little bit instead of trying to remember where things are. But you'll notice here, they want to unclick it, but the .NET Compiler Platform SDK, and that is under Visual Studio Extension Development. Why it's there, I don't know, but that's where it exists. This is something you want to make sure it's on because you're going to get the project templates that I mentioned before, and I'll show you what those look like when you want to create a new project. And you also get a tool window called the Syntax Visualizer, which can be extremely helpful when you're trying to figure out, I want to look at this aspect or this part of my code. I don't really know what that's called in the compiler API, what the class, the type names are or anything like that. I find it very useful when I'm building analyzers to write some code and go, okay, well, what does this actually look like in the compiler API? So again, I'll demo this later to show you what that's like, but that's something you definitely want to have installed. If you're using Visual Studio Code, you can develop all this stuff and references all the NuGet packages. That's all fine. But if you're using Visual Studio, that's a SDK you want to make sure you have installed. Okay, so the first thing I'm going to show is analyzers and code fixes. And the ones I'm going to show are ones that I've built for a library called CSLA. It's a business object library that has been maintained and written and extended by somebody who actually works where I work. His name is Rocky Latka, and he's been building this for 20 plus years. I'm not going to go into what the library does in specific, and it's something that you may or may not find useful. I like some things about it, and there's some things I don't always like about it, but I've used it on projects before, and it definitely has some really nice places where it fits in well. Okay, but what I'm going to show is some analyzers that I wrote for the framework, because the framework, like many frameworks, has some conventions, some opinions, some things that you have to follow that if you don't, things might not work very well when you actually run the code. And that might be something that you've run into in the past with either libraries you've written or you've used. One of them that I can remember is WCF, Windows Communication Foundation. So I haven't used that in many years, but when I did, one of the things that you can do is actually create what are called one-way operations. Okay, and what a one-way operation is in WCF, if you mark a method as one way, is once the service gets the call, it can continue on and do what it wants to do. The client can move on and do other things. So it's a fire and forget scenario, which can be very, very nice to have. The problem is that your operations can't return anything. They have to be void methods. But at compile time, the C# compiler knows nothing about that rule. So it will happily compile it for you. Only when you try to run it, host it as a service, would you actually see an error. Okay. Well, that's kind of too late. I want to see that I have an issue with my code before it gets that far. Okay. So that's another example of where you'd want an analyzer. If you wrote a is one way operation in WCF, you want it to tell you, hey, you can't return a string, you can't return an int, you have to return or return a void. You can't have your method return anything. So there are other things like that in CSLA, and I'm going to show you a couple of them by running this V6 project first, and I'll explain where these projects come into play in a moment. But let me just run this project, which is actually going to open up another version of Visual Studio, which takes a little bit of time.
Jason, while that's happening, had Tim mentioned that you can search for individual components in the installer.
Oh, you can? Okay.
Yeah.
I didn't. Okay, now you see. Now you got me curious. Shouldn't have done that. I didn't know that you could. So, because if I've looked before and come on, checking for updates. Yeah, I know. Did they say where? Did the person say where?
Just in individual components tab. So I guess the second tab there.
Aha! See, that's why I love doing these. That's why I love talking to other developers, because you learn about things that you had no idea about. Cool. So if I said compiler API here, there you go. Awesome. Thank you.
Nice.
That's all right. Good thing to know. All right.
Yeah. I was just going to say, do you want to minimize the window down the bottom right?
Just get that out of the way there. Okay. So what this V6 project does is open up another instance of Visual Studio, and I'll explain why it's doing this later on. I'm going to open this project, which allows me to see the analyzers in action. And once it finally gets everything loaded. So the specific analyzers that I'm going to look at are based around looking for things in what are known as rules. So business objects have this concept of state and behavior, and the behavior needs to, the state needs to be validated through these rules. So you can write these rules to say whenever a property changes, run the rules based on those properties, and then it will tell you through a collection of broken rules what's not correct and what needs to be fixed. Okay, and the way you do this is by inheriting from this class called business rule. Well, for long story short here, before we even had async and await, if you wanted to write an asynchronous rule within CSLA, what was provided is a way to do an execute, and you had to mark your method as actually async void. You may wonder, why are you doing it this way? Because you're not supposed to have async void methods. This is kind of a holdover from things that were done in Silverlight and trying to support the ability to do things in an asynchronous fashion in Silverlight, because CSLA did for a while. And this really isn't the way you want to do it anymore. But as we all know, sometimes you add things in, and then to support how things work in certain scenarios, and then that kind of goes away, and then you're like, well, how do we remove this, or how do we get rid of this? So the way you do it before is you'd inherit from this class, you'd override this method, and then after you do your stuff, you'd have to call this complete method on this rule context, because that would actually tell CSLA the rule is finished, and now I can go and continue on with whatever work it needs to do. Okay. Obviously, this is not something that you want to do now, in part because there are other analyzers like FXCOP and other things like that may look for methods that are async void and tell you, hey, you shouldn't do this. This isn't something that is recommended because it can run into a bunch of problems unless you're using that for an event handler. So I thought, well, couldn't we give users something to tell them that if they're doing it this way, to give them an error, but not also tell them that they're doing something wrong, but also provide them a way to fix it automatically. Okay. Because what you want to do now is derive from this class, which would mean you override this method. The return type is now a task, and there's no reason to call complete anymore. In fact, you shouldn't. Okay, so it's a convention that people should follow. But rather than having people try to manually figure out how do we find all these cases in our code and change them ourselves, is it possible that we could automatically do that for developers? And so that's the thing I'm going to show here is the analyzers and code fixes that I wrote to handle those cases. Okay, so in my solution, I have a couple of projects here, and the way I got these projects in place for the solution is if I right click, I'm not going to add it here, but I will just at least show you where those are in add new project. So if I say here, analyzer, and of course it would freeze right there. There we go. So you'll see if you've installed that SDK, you'll see analyzer with code fix. Okay. And then when you add that into your solution, you'll get 3 projects. You'll get the analyzer project, a test project, and I think it's MS test by default. I'm not sure. And then you also get this V6 project, and a V6 project is an extension project. That's a project type that's been around for quite a long time in Visual Studio. Writing extensions can actually, if you've done it before, I'll just say it feels like you're still in C++ COM world, because you kind of are. If you're trying to extend Visual Studio itself, that product has been around for many, many years, and it was based on Win32 type coding styles in C and C++. So it's not the easiest thing in the world to write extensions for Visual Studio. You don't have to worry about that though in this case, because all this extension is doing is like what I showed. It's going to open up another version of Visual Studio with your analyzers installed there and only there. Okay, so it gives you the ability in kind of a controlled hive or a controlled space to test your analyzers out to see are they doing what you expect them to do. Okay, the main stuff is going to be in that analyzer project. Okay, and the template that's made is, it will have an example. It's kind of a contrived example. I think it's looking for class names that are all lowercase or something like that. So it flags those, and then it has a code fix to change them all to uppercase, which is pretty silly. Nobody would ever want to do that, but it kind of shows you the machinery of what you need to have in place to write these analyzers. Okay, so I've obviously updated this to have a whole bunch of analyzers in here. And let me just make sure I've got the right name here. I tended to be kind of overboard with the names of the classes here, and I felt like I was writing Java stuff because they're quite long. So this is the first one. This is checking for the case where you are inheriting from the wrong base type and you're not overriding the right method. Okay, so that's what this one's looking for. You'll notice a couple things here that I have to have a Diagnostic Analyzer attribute on there. You can write analyzers for both C# and VB, but for many reasons, we're just focusing on C# for the analyzers. These attributes are also there because tools like Visual Studio, when you reference an analyzer project in another project, that it's using MEF, Microsoft Extensibility Framework, to find your refactorings and your analyzers and to load them. Okay, so that's in part why you have some of these attributes there. But you also will need to inherit from certain types based on what you're doing. In this case, you need to inherit from a diagnostic analyzer, which will start to force you to override a couple of things. One of them is supported diagnostics, so you can say, these are the things that I'm going to essentially look for. These are the problems that I might be able to find. And those are all defined via these diagnostic descriptors. They're literally just descriptions of the cases that you're going to find. And so all the things that you see in this diagnostic descriptor are basically titles, messages, what's the severity of it, and so on. Okay, and you can also provide a help link. I highly recommend, if you can, to have help links, because if you're ever in the error window down here, which you can see, the code has a link that you can click on, and that's actually what will go. That's where Visual Studio will go based on the link that you have here. So that can be a really nice thing. I appreciate when people write analyzers that actually have help URIs to give more details as to why that's actually telling me something wrong. Okay, so that just describes the case or cases that you're looking for. Initialize is basically the only method you really need to override. These two methods here, I never had to do when I started writing analyzers. Only in recent history did Microsoft recommend that you put them in here. And what's funny is when they updated their own packages, which if you look at the CSproj file for the analyzer, you'll see here are the packages that are automatically added in for you, the analyzers and C# workspace. Okay. Once I got to a certain version, they also have their own analyzers that will tell you, hey, you have overridden initialize. You really should put these two methods in here. Here's a code fix, and I'll put them in for you. It was kind of, let's see if I can actually get that to happen. If I uncomment these, will it actually tell me that, yes, you'll see down here now, and hopefully if I zoom in, it's not going to look, it will still look okay. Enable concurrent execution. Okay, that was pretty surprising because it would essentially tell me that I needed to add those methods in. You see that I just have this light bulb here, and it's telling me configure generated code analysis. That was done with me hitting Control period on my keyboard. Or you can just, if you ever click on something within Visual Studio, you'll sometimes see that light bulb pop up, and you can just click on it. Okay, so there's reasons from a performance standpoint why they wanted these things in there for analyzers. And I thought that was just awesome that they're actually, it's like that meme where I forget what the rapper is, but you know, like you need analyzers to write analyzers for your analyzers. It was kind of funny. I found it funny. Anyway, so those two are mostly just for concurrent execution within a tool like Visual Studio. This is the one that you mostly care about, because what this does is it essentially says which parts of a tree do you really care about, because you don't want your analyzer to fire every time your user is changing something in code, because you may not care about it. In my case, what I'm really looking for is anytime a user is declaring a method, that's my starting point. If you're declaring a field, if you're declaring a type, that's not what my rule is going to trigger on. I really don't care about that. Okay. And so you see the syntax kind, method declaration, where are these things coming from? So if I go over here, the syntax visualizer, which, where does that actually, show up? Well, it's under View, Other Windows, Syntax Visualizer. Okay, so that's what comes with that part of the installer process that I mentioned before. Okay, so I'm going to bring that up again, and I'll pin it. And once I click in the window here, what you'll see on the left is the tree, the entire tree for this CS file. Okay. And so I've clicked on this method definition. If you look over on the left, it's a little hard to see because I'm in dark mode, but this identifier token is what actually relates to the thing I just clicked on. But if you look at its parent, it's the method definition. And if I click on that node here, you'll notice now that the entire method gets like highlighted in light gray. Okay, so this is, again, I may have said this a couple times already, I'll say it again. This is highly useful because I can kind of, I do this a lot in analyzers. I'll write code within the class, just some kind of test code, look over at the visualizer to see what are the nodes, what are the values over here, the properties, what are the things that I may want to look at, because the API is rather large, and it's something that, unless you're working on it on a day-to-day basis, trying to keep that all in your head is just impossible. But this tool makes it easier to help you kind of figure out what you're looking for and where to go in your search. Okay, so keep that one in mind, very useful. In my case, again, I'm looking for method declarations. So anytime a user is changing or creating a method declaration, or when people are just compiling code, one of the switches to the compiler is actually, I think, /A or something like that. But there's a compiler switch that allows you to pass in analyzers, and those are run during the compilation phase as well to just tell you, hey, there's other things that are potentially wrong with your code. So every time you run into a method declaration, this method gets called. This cast is okay because I know it's only going to get called if I get a method declaration syntax. So if it doesn't contain diagnostics, then I'm going to start to actually look at this method node. But these syntax nodes we're essentially coming from the parser. They give you a sense of the structure of the code, but they don't have a lot of type meaning. They don't have a lot of good information that you really want to figure out aspects of that particular node in the syntax tree. For example, in a method declaration node, if I remember right, if I say method node here, there is a parameter list, but if you look at the parameter list, yeah, it's not even, there's no way to index it. Even if there was, the things that are coming from the parameter list syntax are just kind of syntax nodes themselves. You really want to find out more type information about those nodes. So you want to go at a level higher, so to speak. And that's what the semantic model is. It feels analogous to the reflection API. It's not exactly the reflection API, but it's close to it. Okay. And what the semantic model gives you is more information about those nodes that you're looking at. In the case for a method symbol, it can start to give you information about its containing type. Okay. And I use that to figure out a couple things. First of all, I have this extension method called isBusinessRule. So if I look at that, what this code is essentially doing is saying, is the containing type deriving from any of those business rule or business rule async types that I mentioned before? Or does the base type or any of the interfaces, are those business rules? Okay. So you can't like do a type comparison, because again, this isn't the reflection API. This isn't types. You actually have to kind of look at the names of the type here, the containing assemblies names. These are all just constants that I've created that have well-known names. Okay, so if they match, then that tells me yes, you actually have a business rule. Because if this isn't one of those types, then this is a method I don't care about. I'm just going to stop looking. Okay, if that first case is true, then the next thing I'm going to look at is to say, is the name of the method equal to execute? Okay. Execute async I don't care about. All I care about is, well, are you actually a execute method, and are you an async one? Because it's okay to have synchronous rules. Those have been around for years. You may be just doing a simple CPU bound calculation, that's fine. But what I am looking for is if you're creating a business rule that's called execute, that's async, because that's wrong. And if that's the case, then I do this report diagnostic, and that will inform either the compiler or in Visual Studio that something's amiss. You'll get a squiggle, and in my case, because my diagnostic descriptor is severity of error, it's going to be red. And then it will show up in the error list and tell people something's wrong. Now, when I launched this with that V6 project, you saw the red squiggles, you saw that those errors were coming up. But if you can install these extensions or these analyzers as a Visual Studio extension, or they can be installed as a NuGet package. you want to do it as a NuGet package, because in that case, what will happen is when the rule breaks or the analyzer breaks, it actually makes the compilation fail. If they're installed through an extension, they'll still show up as errors, but the build will still succeed. And there's reasons why they did it that way, but that's the difference between the two. So, having this project here as bundled up as a NuGet package and referenced that way is the better way to do it. Okay. So if we run into this case, this is where we're telling the user you've done something wrong. But we also want to provide a way to fix it. Okay. And that's done in this class. This is a code fix class. Okay. And again, we have some attributes that we need on our class itself. We also need to derive from code fix provider. Okay. So there's a couple things that you need to do in your code fix provider. You need to specify which analyzers you can fix. Okay. So that's what this fixable diagnostics ID property does. And this is essentially the identifier for the diagnostic that I have in my analyzer. So that kind of is the tie-in between the two. Okay. And then you're going to override register code fix async, because this is where you're going to figure out how do I change the code so that it's no longer in a bad state. Okay. This code here just kind of gets me back to the actual method node within the tree. And then in my add code fix async method, this is where I'm actually going to make all my changes. Now there's a lot in here. I'm not going to go through all of it, but the thing I want to kind of stress with this implementation here is trees in the compiler API are immutable. So you never actually change a tree in line, so to speak. If you're going to provide a code fix that has the fixes within that tree, you actually are making a new tree. And this is important because if I was actually changing the code itself, this would actually change the code on the user within the code window, and they might go, hey, wait a minute, don't do this. I don't want this code fix, excuse me. So there's also a lot of other reasons why they did this as immutable, because they can do things concurrently. There's a lot of things just with immutable data types in general in coding that have some nice aspects to them. But keep that in mind, because when you're changing trees, you're always getting a new copy. You're not changing the tree itself. Okay. So one of the things that I want to do in this code fix is change the base type. Okay. So I look at the type node for where that method's declared, and I get its base list. You're also going to see things like with trivia from. Trivia is your white space, your tabs, spaces, line feed, carry returns, comments, everything like that. That's all considered trivia. That's all captured within a syntax tree, and you want to keep that around because you don't want to lose any of that. Otherwise, the formatting is going to look kind of weird. So that's one thing to keep in mind with code fixes, is keep track of the trivia and make sure it comes along for the ride as much as possible. What I also do is then look for the current method node with execute. I want to change the return type here to now be a task. The syntax factory class, this is another one to keep in mind because it has a ton of methods on it where you can build like await expressions, you can build checked expressions, you can build a whole, for expressions, identifiers, everything that you could think of within a tree. And it's a really simple way to say, hey, I need a new method declaration, I need a new parameter. The syntax factory has all those methods to make that easier for you to do. So in this case, I want to create a new identifier based off the name of task, surrounded with the trivia from the current return type on the method that we have. And then also I want to create a new identifier called execute async. Okay. So notice here that I get a new method with my new return type with a new identifier. Okay. And then I take that new method node and I say replace the current one, and now I've got a new type node. That can also be exchange for the current type node that I have, and I want to replace that one as well, and I get a new root. Okay. I also can say, hey, wait a minute, make sure we got the system threading task as a using statement on top, because if we don't have that in our compilation unit, we want to add that in if possible. Okay. So that's what this add usings does as well. It allows me to add in a using directive for the task type if it's not there. And then you just register the code fix. Okay. Now, again, this hopefully conception makes sense. There may be details here. It's like, why are you doing this here? I don't quite understand what I need to do in every case. I'm not trying to simplify this too much because, again, writing analyzers and code fixes, I can explain it in about 20, 30 minutes, the basics, but it does take some time to truly understand what you can do and when you need to do it and in what order. That does take, it's not a trivial endeavor. I definitely want to make sure I get that point across. But the thing to keep in mind is, like with the analyzer, this is really the heart of it. The rest of it is just kind of setup stuff that you need to do. This is really the heart of it. And that's, even though this is an extension method, there's only like 10 odd lines of code here. For the code fix, it's essentially all this stuff, and that's, I don't know how much I've got highlighted there, but it's not a lot. What's interesting about writing these analyzers and code fixes is once you kind of figure out what you want to do, the amount of code that you need to write typically is not going to be a lot. It's not as much as you may think it would be. Okay, so again, now that I've gone through this, if I go back and say on the V6, let's run it again and see what it does. Because I just showed you the squiggles. I just showed you the analyzer portion. So if I pick my integration test project here, and once that comes up, now when I have my rules kick in, which it does take a little bit of time, there we go. You can see that this is telling me my stuff from my diagnostic descriptor. And if I do my control period, you'll see that I get my code fix coming up. And this is also a nice aspect of why these trees are immutable, because I get this little diff window that pops up and it'll show me, hey, this is what's about to change in your code. Do you want to accept it or not? One other thing to notice down at the bottom here, if I zoom in, is when you have these code fixes come up, is that you might, it depends on the analyzer and the code fix, but you might get the option to say, hey, change it in the document, the project, or the entire solution. So this is really nice, because if you ever want to accept a change that's coming from those light bulb scenarios, you can say, do this for everything in my solution. So if this would occur in other places in my solution, I can just let Visual Studio do a one and done, and I don't have to try to find every single occurrence of those. I can just let Visual Studio do that for me. So that's extremely helpful. But if I just say, yeah, accept this, that's fine. Do that again. No, come on, let's do it. Come on. Did it? It changed. Wait a minute. Yeah, it changed it on me. See it. It's early for me. I'm sorry. I need more coffee. There you go. So it changed return type, changed the name of the method, and it changed business rule async. Okay, now there's still a squiggle here. It's because it's telling me that I don't need to call complete anymore. That's another analyzer and a code fix that I have that also gets rid of those cases as well. Okay. One of the things I've realized that when I built this is I should see if I can get that to actually all happen at once. But for whatever reason, when I wrote this, I didn't do that. So that might be something I kind of combine in to say do that all in one shot. Okay, but that's essentially what analyzers and code fixes give you. Okay. All right, 429. Let's undo that. close that out. And by the way, you don't have to just test your analyzers and code fixes and refactorings within Visual Studio. You can also, I won't show them here, but you can write unit tests to test all this stuff out in unit test projects and make sure that everything works. I just like that V6 experience as well, because that's kind of my end user testing. You know, yeah, the unit test passed, but does it actually work the way I expect it to within Visual Studio? All right, let's see here. Let's go to a refactoring example. This is called auto arrange. And let me make sure that I am getting it from the right spot. That is in there we go. There we go. Yep. Okay. So refactorings are things that are essentially, my code isn't wrong, but I may want to change it in a different way. Like I've written some code and I want to pull out a part of that code within a method and make a new method. So Visual Studio has a ton of those refactorings where you can create a new method based on the code that you've highlighted. You can introduce locals. You can, change for each to being a link syntax or vice versa. None of those changes actually, or they shouldn't change the behavior of your code. That's what a refactoring does. A lot of times I hear people say, I'm refactoring my code, and what they're really doing is restructuring everything, putting in totally new implementations and breaking unit tests, which is fine. Sometimes you have to add in new features that are actually changing the way your application behaves, but that's not refactoring, that's restructuring. The Martin Fowler book from many years ago on refactoring, it is saying you're changing your code so that's, it's more maintainable, it's easier to read, but you're not breaking behavior. Okay, so that's what refactorings are. And this one is just, it's kind of a little bit of a contrived example, but it's trying to demonstrate cases I've seen on projects where we're trying to enforce certain coding standards. Many years ago, I was on a project where we were brought in as consultants, and they had their own coding standard, which was in like a 50-page document. We had to remember it all in our head. And we started creating our first changes, and we started getting immediate pushback that we didn't know what we were doing. We were terrible coders. That's because we were putting the opening curly brace on the next line, not the end of the line, which is the way they wanted it to be done. Which I'm a fan of consistency, but there's also a part of me that said that's a little bit of a bridge too far for me. More to the point is, I want those types of formatting styles to just be automated. If you pick tabs or spaces, I do care. I like tabs, but I mostly care about, are we being consistent in our code base? And there are things now like editor config files that can enforce a lot of those formatting standards for you. And there are tools, I think there's a .NET tool called Format that you can run, and it will just automatically format all of your code based on editor config rules. So that stuff is really nice. And it just takes away you having to think about what is the standard for our formatting. Users don't care about that. Let's just use tools to automate that for us. So it's kind of what I'm doing here is, do we have like a rule in place that says that all of our code needs to be formatted such that members are in a certain order in our classes and they're also alphabetized? Try to do something so silly like that. I don't want to have to remember that every time I'm writing new stuff in my class. I just want a refactoring to do that for me. Okay, so that's what this refactoring project does. Again, you would go into a solution and say add new project, and there is a refactoring, and you'll see a code refactoring type here. Okay, now these refactorings were first not available as NuGet packages. I believe sometime in recent history they've added the ability for you to install refactorings as NuGet packages. It kind of makes sense because refactorings are solution-wide. They're not usually tied to a specific project, but they now have made that so you can I believe, package them up as NuGet packages. I don't know why the template doesn't provide a unit test project out of the box either. So I had to add that test project in myself. Okay, but this is the refactoring class that you need to have in place, the structure of it. Again, we have some attributes we derive from code refactoring provider. And then we have one method to override here, which is compute refactorings async. And that's where you just say, hey, based on what I'm looking at in code, can I provide a refactoring? So this is a little different. Refactorings aren't run all the time like analyzers are. They're only run if, like, I'm going to do this, and if I hit control period here, I don't get any refactorings. Okay. If I do this, now I do. Now I get the extract method refactoring. Okay. So something that has to be manually invoked by the user, and only if it makes sense based on what they're looking at or what they currently have highlighted. Okay. So in this case, what I want to do is say, hey, the node that the person is currently on, is it a type declaration syntax? Either a struct or a class. If it is, then I'm going to run this method here. And essentially what I'm going to do is I'm going to look at the type, and I'm going to run 2 visitors on it. Okay. The first visitor is this capture walker, and it derives from a class called C# syntax walker. That's how the compiler API. Okay. And so what the capture walker does is it's going to go through the declaration and say, I want to find all the constructors, enums, events, fields, blah, 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 all the things that can exist within a type. Okay. And then in the visitor, there's all these methods you can override to say, I want to be told when you found certain things within the node that I gave you, okay, like fields, constructors, and so on. And in this case, whenever that happens, then I'm going to populate these lists with those members. Okay, so I'm essentially capturing where they all exist within the definition. So that's the first part. Okay, and then what I'm going to do is essentially reorder them with this syntax rewriter. Again, this is all immutable, so this is only going to change in a new version of the node. Okay, so in this rewriter, I pass in the reader, the thing that I captured all the stuff in on construction. I then resort all of these things so that everything's in alphabetical order. And then I put them into a big list. This is not optimized, but mostly for demo purposes. Put them in a big list to say, hey, I want to have the events first, then the fields and the constructors and so on. Okay. And then you'll notice over here that I say visit the type declaration. And when that happens, you can see with all these methods, I'm only going to just call replace. Because what replace is going to do is it essentially says, I keep a track of an index, and I essentially say in the reordered big list that I have, basically fill in all the places where things currently exist in the type definition. So it's basically replacing everything in the current one with the order in the right sequence. Okay. And so once that happens, what I'm going to do is say, well, the thing that just came out of this, is it different than what I have right now? Because maybe you're in the right order and nothing changes. Okay. So this is where, like what I just showed with the extract method refactoring, is only if a change actually occurred am I going to register a refactoring. Okay. And if that refactoring is accepted, then the code will actually change. So again, I have a V6 project in here. That's this one. We'll make that the start up and run it so you can see how this works when it actually runs. All right, so we have this test project here. And I should have a couple of types within this code that has everything kind of out of whack, out of sequence. Okay, so for example, on this sorted class, You'll sometimes see what looks like a screwdriver over here as well. There's quick actions that you can sometimes get. There's lots of stuff that pops up in Visual Studio. But if I say here, control period, I'm not getting my refactoring. And the reason why is because things are actually in the correct order. What I have to do is actually move them out of order. Okay. And now hopefully I get, yes, my refactoring showing up. It's going to tell me that these are going to be flipped around, and there we go. Okay. This one is hopefully, I think everything is, of course not. It actually saved it from my previous demo when I did this with everything in the right order, but that's okay. I can just grab stuff and put it over here and pull this one down here. Okay, and then also I'm going to take this internal or this nested class and make it wrong as well. So now in this case, I get my refactoring. Notice that the nested class, it's also going to get that rule applied to it and have the methods in the right order as well. Okay. Now this is, this is all fine and refactorings are great, but kind of what I just said about editor config files and the .NET format tool is I'd like this to kind of be automated. I'd like this to happen every time I save my file because I don't want to have to remember to do control period and auto arrange every time. I'm not going to demo this because this gets pretty complicated, but you'll notice there's another V6 project in here. And this is actually an extension project. And what I did in that project is I actually added the ability to hook off of a document saved within a project. And whenever that occurs, just automatically run my refactoring code on all the types within that CS proj file or that CS file. Okay, so that way I can just now have an extension that takes that refactoring and applies it every time I save code in my file, and then I no longer have to think about it. Nobody has to remember the rule. Nobody even has to remember to run the refactoring. Yeah, so I'll just kind of leave that if you want to take a look at the code and see how that works. It's complicated because again, writing extensions is not the easiest thing in the world, but it's fun when you actually get that to work. Okay. The last thing I want to demonstrate here is I'm going to show you at least one tool that I've written in the time that I have left. David, how long do we want to go on this? I should have actually that on the beginning. How long do we go on this?
Probably yeah, a few more minutes would be all right.
Okay. Okay.
Yep.
So I'll just show you one more tool. This is something that I wrote that it doesn't fit into an analyzer or refactoring or anything like that, but this demonstrates that you can build your own tools to do your own analysis or your own types of things on code and come up with a whole bunch of new things. Okay, so do I have it in my list here? No, I don't. That's okay. I'll go grab it from your config generator. Okay, so this is a tool that I wrote. It's actually called the .NET Core Global Tool, which those are just executables that you can make as packages and then put up into NuGet. But what this tool does is it essentially generates an editor config for you. Okay, so in the interest of time, I won't get too far into the weeds with this one, but just to kind of show you what happens here is if I go to my styles folder here, I should have, there, you can see here these styles, there's a whole bunch of things that I'm checking for. And these are all based on the values that you can put in an editor config file, which if you've never seen an editor config, just to quickly show that, I do think I have one for this project. Yes, I do. Okay, so this is what an editor config looks like. You can see here for var, I actually like using var. I don't like putting in the full type name. So I can set this in an editor config, say it's true, and then I can also say it's an error. I really want to enforce that people are using var instead of a type name. You may do something different, so you can set whatever you want in your editor config and the suggestion severity levels as you see fit. So the problem is that creating those can be kind of tedious. And so I thought, couldn't I just take code that people have written and analyze it and figure out what your style is for you? So you'll notice, for example, this code here is essentially, I'm getting a local declaration syntax. And again, there's a lot of machinery that goes into place to parse the file, walk it, and update all my style classes to figure out what preference you have. In this case, I'm looking for local declarations. Okay. In the case where I have a local declaration, I'm essentially trying to figure out, are you actually using an identifier name or the var keyword? You can see here, that's where the magic happens. That's where I check to say, is your identifier var or is it something else? And then if it's var, I'm gonna update my statistics to say you like var more than you like type names, or vice versa. And then at the end of the process, I'm gonna spit out all the things that I can find based on the code that you have. So to demonstrate this, I have a little test project over here, and I use this test project where I can actually do a bunch of things where I automatically clone a bunch of repositories from GitHub to just run on and say, and mostly to make sure I don't crash and that I actually, get at least something that's producible. Okay, but I've changed it so I'm only going to look at one repository that I have, and I'll run that now. And what you'll see coming through is it's going through all of the files in this solution and project and just going through all the CS files and figuring out what my style is that currently exists. And once it gets through all of them, what you should see at the bottom is here are all those styles. So it would save it in a editor config for me, but I also print it out in my console window so you can see what these are. Okay. So this is just another illustration where you can take the compiler API stuff and build other tools that can do all this analysis and code for you. There's really no limit here. I've actually, another demo that I have, but I'm going to skip it for now, is what's called rocks. It's a mocking library. If you've ever used MOQ or nsubstitute, you know what mocks are. The rocks library I wrote is a mocking library that builds all the code from C# snippets, and it uses the compiler API to build them up. The nice thing about that is that I can actually save my class that I generate on the fly to disk with debugging symbols, and then I can step into the code when I've run it. And that's really helpful. The libraries like MOQ, they use IL generators, and that's pretty nasty. Like, it's really hard to figure out what's going on. So being able to debug it, which is literally just like a switch to say, hey, I want to generate debug symbol information. Then the compiler handles all the hard machinery to make sure that that works for me, and I can just step into it, and it's really nice. So that's pretty much all for the demos. The last thing I want to mention is kind of what I just hinted at, which is, I was able to generate code, mock types for unit test scenarios. Well, there's now something called, or it's coming for C#9 called source generators. Okay, I'm not going to demo it. I have all the links in the slide deck if you want to take a look at it. They do have this available for the preview version of Visual Studio. It's a little rough right now. It is long story short, it's a little rough to use. But what source generators are is a way for you to say, I want to generate code based on what is actually being written by a user. Okay, so the classic example they use is iNotify property change, because that's something that is rote, it's trivial, it's repetitive, and why can't I just have something build this for me all the time? And so source generators can be used for that and many, many other scenarios where you can have a source generator build code for you based on what's actually happening in the code. So this is another thing to take a look at. This is an extremely powerful feature, and if what I've shown you tonight looks interesting, then I would also take a look at this, because there's a lot of power and possibility with this feature coming in C#. Yeah. So now I am done. That's all I have. I've been kind of looking over at the QA. I don't think there are any questions coming through. Is there anything else or any questions that people have on what I talked about?
No, I think that's been it so far. We'll just give people a chance if they do want to type in, just because there's a bit of a delay until people hear our questions. Yeah, no, when you were describing that project, I was thinking source generators, and so I'm glad you mentioned that. Something I have to have a bit of a play around with myself, because I think there could be some interesting applications for that. So looking forward to seeing how they evolve.
Yeah, I've run the Hello World, and I got that to work, but right now you can't step into the source code that you generate. They will get that working, but right now they don't. So that makes it kind of hard to figure out what you did right or did wrong. There's some other things that they don't support. You know, the tooling experience is really the rough part. It's not the greatest right now, but again, it's a preview, so that will all get shored up over time.
Yeah. Yep. Cool. All right. Well, thank you, Jason. That's been a really interesting talk. I hope people enjoyed that, and yeah, either got something out of that or have got inspired to go and apply that. It was really interesting to see how you're using those sort of in different ways. I've had a bit of a play with analyzers myself, but you've really dived into it, which was great, and really appreciated you joining us this evening. And yes, I hope you don't suffer too much for the rest of the day for the early start. So
all right. Well, thank you for having me. I appreciate it.
No worries.